What's going on, guys? It's Orok here with Ming Tech Media, and today we are going to be discussing traversing an array from both ends. This is also known as a two-pointer approach, and for some problems, it's best and more efficient to use two pointers, one at the end and one at the beginning of the array, and have them converge toward the middle to come up with some sort of solution, right? So let's take a look at this problem. Let's say we have an array, right? And we have to reverse the elements of an array. So given an array of integers, array of integers, reverse the array. Oops. All right. So let's just say we have our example, right? And this is our example 0, 1, 5, 6, 3, 9, and 4. Right? And one thing to note is that this array is unsorted, as you can see here. So what we want to return is we want to return a result of basically the opposite. So 4, 9, 3, 6, 5, 1, and 0. 0. So that array is completely reversed, right? So one way to solve this is to allocate a new array of the same size and traverse from the back to the front, adding the element at each iteration to the output array. So basically something like this. This is a what? 1, 2, 3, 4, 5, 6, 7. This is a 7-element array, right? So we allocate a new auxiliary array. So I'm going to just say aux array. Right? And it's a 7-element array. And what we want to do is we want to start from the 4 and traverse down to the 0, or start at the end and traverse to the front. And we're going to, at each iteration, add that to the beginning of this array. So we'll have like a pointer here as well, and a pointer at the end. And we'll start from the end of the input array, and we'll traverse to the front and add each element in the array to the auxiliary array, right? Now, although this seems like a really good solution or a very practical and straightforward one, it does, use up extra space. So this is, space complexity. That space complexity is O of n. Because whatever this input array size is here, we're going to have to allocate extra space in an auxiliary array of that same size, of whatever this n size array is here, and add the elements from the back to the front to this auxiliary array, right? So that's O of n space. But what if we wanted to do this in place? How would we do this? In place. So one of the ways to do this, and one of the best approaches to do this, is to use two pointers, right? And the logic behind that is I'm going to, have a smaller test case here. So we'll have like, let's say 1, 7, 2, and 5, right? Just a smaller array. And what we will do is we'll have like a start and we'll have an end here, and they'll converge towards the middle, right? So this will increment start and will decrement end, and converge them to the middle. And so for every iteration, we want to swap the two elements, right? Until, these two pointers, they meet each other. So for the first iteration, what we're going to do is we're going to swap, and then we're going to increment start and decrement end. So what we're going to do, we swap. Let me just erase this here. We swap the 1 and the 5. So 5, 1. And then we traverse the array from the back and the front using these pointers. So we're going to decrement end. End is going to be here now. Start is going to be here now. Let me just erase all this. So this is our new end. This is our new start. And what we want to do after that is just swap them. And our terminating condition is our base case, or the condition in which we break out of this loop, is as long as start is less than end. And if that condition doesn't hold, 7, 2. If that condition doesn't hold, then we break out of the loop, and this will terminate, and we'll have our result, our reversed result. So what we're gonna do is we're gonna do this in Java. So you can accomplish, like I said, you can accomplish the same thing with 2 pointers by swapping them and moving towards the inner part of the array and moving inwards. So what does that look like in Java? So I'm gonna erase all this, and we're gonna code out a solution in Java. All right, guys. So we already know that we want to do this in place. We found that the in place solution is actually more efficient. The earlier solution I mentioned about having a pointer starting from the end of the array and allocating auxiliary space, and adding elements from the end of the array to the front of this auxiliary space array, that's a plausible solution, but it's not efficient because, like I said, it depends on the size. The space complexity depends on the size of the input array, which is all event space. So we don't want that. We want to do everything in place. So bearing that in mind, we definitely know that our method signature is going to have some sort of void return type. So I'm going to say it's going to be public static void. And we can just say reverse array as our name. And what is this going to take in? This is going to take an integer array, and that's it. We don't need anything else. So we have an integer array, right? And so what's the first thing we want to do? We want to just first check if that array is null. And if it's null, we just want to return. So if array is equals to null, we want to return. So we'll return that. All right, so what else do you want to do? We said we're using 2 pointers, so let's go ahead and declare those 2 pointers. So we have int start, and we'll set that equal to 0. And then in end, we'll set that equals to array.length minus 1. And that just gets the index of the last element. So after that, we want to have a while loop. Like I said, we want to make sure that start is less than the end. So while start is less than the end, what do we want to do? We want to swap. We want to perform a swap and then increment the start pointer and increment the end pointer. So I'm just going to say swap here and do array, and then we do start and end. And we'll implement this swap in a bit. So then we do start plus plus, and we do end minus minus. And there we go. We had our 2 closing brackets. And that's our solution. Now let's implement that swap function. So this is another void return type because we're doing in place work. So public static void swap, and we take in an int array, and we have int position 1. I'm gonna say pause 1, and int pause 2. And it's very simple. What we need to, it doesn't look like a curly brace. So what we need to do is we need to declare a variable called temp. Set that equals to array pause 1. Then we take array pause 1. We set that equals to array pause 2. And then we take array pause 2 and set that equals to temp. And there you have it. That's your swap function. So, and if you're using a collection, right? There's a special method in Java called I think it's util.swap. So if you're passing this some sort of collection instead of like an array, instead of implementing this as like a built-in method, you can use I think there's also one called collections.swap. So you can use these on like collections instead of having to implement this swap function. And for interview purposes, a lot of interviewers they won't really like, I mean, you can if you have time, but time is of the essence in these interviews because, ideally you want to solve these problems in less than 30 minutes, 20 minutes or so. So functions like this, a helper function like swap, sometimes, not all the time, but sometimes the interviewer may like tell you you don't have to implement it because it's so simple and you don't want to take time. Or if you're using like a collection or so, you can just use one of these built-in methods here. Especially if like the problem you're solving has a little bit of like complex logic, you don't want to spend your time wasted on like implementing arbitrary functions like this or very small minuscule functions like this, especially when the rest of your logic is more complicated and you have a very plausible solution. So a lot of interviewers will neglect the implementation of swap, but that doesn't mean it's not important. I just wanted to show you what it looked like so you have that understanding. But keep in mind that this is available, like this swap. I'm not going to go into detail about their implementations or inner workings. That's something you can look up yourself. I'll try and include it in link in description to collections.swap and utils.swap so you can look that up. But just I just wanted you to know that exists, or this exists. But other than that, that's it for this tutorial, and I hope this was able to sort of gear you in the right direction and sort of give you an insight as to how to solve an array problem using the two-pointer approach, i.e. traversing an array from both ends. All right, guys, thanks for watching, and you have a great day.